Hi, everyone, and welcome back. It's Kira Garfolo again with Greenville Tech's Math 155. Today, we're going to continue our discussion of Unit 2, and we're going to talk about Section 2.2, which is more in detail about the slope of a line. What is slope? Well, in plain English, slope is how steep a line is. Okay, it's also going to tell us the direction. Is it pointing up or is it pointing down? Pointing up is going to be a positive slope, and pointing down is going to be a negative slope. We can go more in depth here. There's a lot of ways that you'll hear slope described mathematically, but basically all we're doing is comparing how much something changes vertically versus how much it changes horizontally. Okay, so if you're looking at 2 points, how far up or down did we go between the two compared to how far did we go side to side to get to those points? Some of you may be familiar with rise over run, and this is just going to be a fraction. Okay, how far did you go up or down? And then divide that by how far you went left or right. Now be careful with your signs. Up would be positive, down would be negative, left would be negative, right would be positive, okay? Now there are several different ways that you've maybe learned to talk about slope. And if you Google search how to calculate slope, you'll probably find even more than this, okay? In math, slope is often denoted by the letter M, okay? It's often denoted by M. And again, remember that's rise over run, which is no more than how much we change vertically divided by how much we change horizontally. If we have 2 points, the calculation formula is this last piece right here. We take our second point and we look at the y. What's the difference in y's between the second point and the first point? And we're going to divide that by the difference in the second point and first point for horizontal, for their x, okay? Now, usually it's good practice to talk about second versus first, okay? But really, as long as you go in the same order, because sometimes you won't know what came first, what came second, okay? As long as you take the same points, the 2 points, and you do them in the same order for y as you do for x, you'll get the right answer. The signs will work out. Now, sometimes we're going to see it written in an equation, okay? If we see a form of an equation of form y equals mx plus b, this is what we call slope-intercept form. This m is the same as this m, okay? Our slope is whatever that value of m is. I want you to use what makes the most sense to you, okay? Now, I don't have a favorite. I like to use slope-intercept form if I can, but sometimes that's not practical for a problem, okay? We're going to see a bunch of different ways to do it, and sometimes one lends itself to the other, but maybe you have a particular preference, and that's fine. Use what makes sense to you. Now, as I was saying on the last slide, if we're given 2 points, usually the easiest way is to look at the vertical change and divide by that horizontal change, okay? So, if you don't have 2 points though, like maybe they didn't give you the coordinates, but you have the line, you can usually pick 2 points on that line and just use them. I would pick 2 easily findable points, right? Because otherwise it's just gonna be an estimate. If you see whole numbers, that's gonna be your best bet. Let's look at this for an example. What's the slope of this line? Well, the easiest thing to do is to pick 2 points. I'm gonna pick this point right here and this point right here. And I picked these because they intersect at whole numbers, okay? So this is going to be 0.11, and this is going to be 0.0 negative. Now, I could have chosen any points here, but you can imagine that choosing this point right here, I don't know what it is, right? We can estimate what it is. It's probably somewhere around, what, 2.3-ish, maybe? And this is maybe down here 1.7-ish. But notice that that's not great. If we see a good, easy number, besides, who wants to work with decimals if you don't have to, right? So let's work with the points 1, 1 and 0, negative 1. And again, it doesn't matter which one we consider first, as long as we treat them the same. So this is going to be x1, and this is going to be y1 because it's the first x and the first y for our first point. And this is our second point, so this is going to be x2, and this is going to be y2 because it's the x and the y for our second point. So our slope is going to be y2 minus y1 over x2 minus x1, which is going to be -1 minus 1 divided by 0 minus 1, okay? Which is going to give us -2 over -1, which is going to give us 2. Now, you could have done it the other way, and you'd also get 2. As a quick exercise, make sure that you understand that you could have done it the other way as 1 minus -1 divided by 1 minus 0, and that would still give you 2. Okay, so it doesn't matter what you choose as your first point, as long as you do them in the same order. Now, I kind of mentioned this before, the types of slope. If we look at a line and from left to right, the way that we read in English, right? We're looking at the line going this way. A positive slope is if it's pointing upwards, okay? A negative slope if it's pointing downhill. And then, of course, horizontal and vertical. Horizontal is not going up and it's not going down, right? It's staying the same. So our steepness or our slope is going to be 0. A vertical line just drops straight down. And we actually call this undefined slope. So a vertical line does not have slope. And if you think about the rise over run concept, right? If you picked 2 points here and here, let's say that these are 3, 2, and let's say this is 3, -2, okay? We know that they're going to stay at x equals 3. If we think about this, we have 2 minus -2 divided by 3 minus 3. So sure, 4 is our vertical difference, but at the bottom we have 0. Remember, we can't divide by 0. We get an undefined fraction, okay? That's the reasoning behind why vertical lines have undefined slope. Again, the denominator is 0. Now, let's get some practice. This is a great place to pause and check yourself. We want to find the slope of the line that passes through each set of these points. So 1, 2, and 3, 5. Remember, we're going to do this one and this one, and this one and this one, okay? So our slope is going to be 5 minus 2 over 3 minus 1, which is giving us 3 halves, okay? And we can just leave it as that. If we wanted to put it in decimals, we easily could in our calculators from 1.5. And I'm doing some of this math by hand, but certainly, remember, you have your calculator. Don't feel bad if you need to use it. I don't trust myself mathematics in head, okay? I'm pretty good at making mistakes. So use your calculator. 0, 0, and 3, 7. We're going to have 7 minus 0 over 3 minus 0. Because remember, we're going to make this x1 and y1. This is going to be x2 and y2. This is going to give us 7/3. Here, we're going to have 3 minus -4 over -5 minus -2. This is going to give us 7 over -3, so -7/3. And here we're going to have 3 minus 2 over 4 minus 4, which gives us 1 over 0. What does that give us? That's not the slope. It's not 1. It's not 0. It's not 1 over 0. It is going to be undefined. And you could always plot these points and look, right? 4, 2, and 4, 3, again, are going to be that vertical line. So you know there's a problem. Let's practice some more. 1, 5, and 3, 5. Well, 5 minus 5 over 3 minus 1 is going to give us 0 over 2. This is going to be 0. This is going to be a horizontal line. And you could plot those and verify. 2, 2, and 6, 6. Don't get misled by seeing the same numbers here. Our slope is going to be 6 minus 2 over 6 minus 2, which is going to be 4 over 4, which is going to give us 1. Okay. This is going to be that y equals x line. But just because you don't see any change between these two, that has nothing to do with your slope. Okay. X and y changing within a single point. You have to compare 2 points. Y's to y's and x's to x's. Well, that's all fun and great, right? We give 2 points. It's fairly simple math. Be careful with your parentheses in your calculator and you'll be golden, right? But sometimes our equation gives us the slope without us even having to do that. And sometimes we just don't have points. And if we have the equation in a certain way, we certainly could solve for some points like we did earlier in the last section, find some points using a table and then find the slope between those. There's nothing wrong with that. But it's a lot more efficient if we just know that sometimes the equation gives us the slope right out. Again, be careful here. Slope-intercept is the only time this works. It must be in the format of y equals mx plus b. You're going to see a number for m and you're going to see a number for b, okay? M is your slope, b is your y-intercept, okay? So you could graph an entire graph here just based on this. You wouldn't even need to find that many points. You can graph your intercept and then you can use your slope to go, up and over. It must be in this format. So consider the line y equals 4x plus 17, okay? Well, think about this. 4x is mx, where m is 4, plus 17 is b. Then we can easily find 2 points that are on the line, right? We could see, okay, well, 0, 17 is on the line and 2, 25 is on the line. If I had wanted to find that, I could have said, well, x and y, what about when x is 0? What about when x is 2? All I did was plug them in with my calculator and I'd get 17 and 25, okay? But that's a lot of extra work. Okay, if we use those points, we see that the slope is 4. But again, we don't need to do any of that. We don't need it. I can't even write, you guys. If you get stuck on a test and that's the approach you take, go for it. There's nothing wrong with that. But just looking at the equation, we can see it. Remember, y equals mx plus b. 4x plus 17 tells us that our slope is 4. Now, if you're given no points, and then you're also given an equation that's not in slope-intercept form, you can solve for slope-intercept form, okay? Solve for y. That's all you need to do. Solve for y and simplify. So for example, you're given 15x plus 3y equals 60. Well, move that 15x over to get this step, and then solve for y. Here, you're going to have y equals 20 minus 5x. Now be careful here because this is in b plus mx, okay? M is your slope, is always, always, always what's attached to your x. Okay, so here, it doesn't matter what order. Remember, addition is commutative. Whatever's attached to your x here, so -5 is attached and your slope is -5. Again, you could have found points, but this was probably a lot simpler. Okay, what's the slope for each line here? Let's start with y equals 3, okay? We have a y equals, so that's good. We don't have anything with x. A couple of things. You might notice that y equals 3 is going to look like this, right? It's going to be that horizontal line. But you could also think algebraically, this is the same as y equals 0 times x plus 3. In either case, we're not going up and we're not going down. We're going straight across. We have a horizontal line. So here, our slope is 0, okay? What about, we're going to move down first. What about y equals 3x minus 1? Well, now we have mx plus b. What is M here? Well, M is going to be 3. So our slope is 3. X equals 4. Well, the fact that we don't have any Y should tip you off that we are in trouble. Okay. And if you remember, X equals 4 is going to look something like this. It's going to be that vertical line. And what do we know about vertical lines? Their slope is undefined. So there isn't a slope. It's just undefined. That is the answer if you're asked to find the slope. Now, what if we have X minus Y equals 4? Well, this isn't in slope-intercept form. So what are we going to do? Well, solve for Y. Negative Y is going to be 4 minus X. We need to get rid of that negative. So we're going to divide or multiply by -1. So we're going to get Y equals -4 plus X. We could rewrite this if we wanted to as X minus 4. This is in slope-intercept form. Remember that X minus 4 is going to be the same as Y equals 1X minus 4. So here, our slope is just going to be 1. Make sure that you can solve these. These are also on your test. This is a great place to pause and make sure that you get a little bit of practice. But we can walk through them. 2x plus 3y plus 6 equals 0. Well, we just have to do a little bit of algebra here. We can move that 6. So 2x plus 3y equals -6. Now we can move that 2x. So we get 3y equals -2x minus 6. And lastly, y equals -2 over 3x minus 6 over 3. And we could certainly simplify that, right? But we don't need to because all we care about is this. Okay? Here, our slope is going to be -2/3. Okay? Make sure you can get this. I worked through it kind of fast because it's the algebra from our first unit, but make sure that you can get it. Over here, we have x equals 2y minus 1. Let's get that 1 over there. So x plus 1 equals 2y. We need to divide by 2. So x plus 1 over 2 equals y. Remember that 2 is going to go to both sides. So that also means that x is going to be x, or y is going to be x over 2 plus 1/2. X over 2 is the same thing as saying 1/2 times x. So our slope here, mx plus b, is going to be 1/2. 2x minus 5y equals 12. So minus 5y equals 12 minus 2x. So y is going to be -12 over 5 plus 2 over 5x. So our m here, our slope is going to be 2/5 because that's what's attached to x. What about this one? 3 minus 8x equals y. Well, it's already in slope-intercept form, right? Y equals, we could rewrite it if you needed to. We could say, okay, well, this is the same as y equals -8x plus 3. So our m here is -8. Voila, that's the slope. If you had a hard time with any of those, definitely pause, definitely get yourself a blank sheet of paper and work on those. This is the algebra that we learned in that first unit, but it's going to be very important throughout this unit. Don't let your ship sink here because of algebra. Now, so far, a discussion of slope may feel like it's just math, who cares? But it's actually everywhere. It's one of the most prevalent areas of math that we see. We all use slope multiple times a day. Every time you drive, every time you bike or walk or run or use your treadmill or your Peloton or whatever, the grade or the slope of a road or a hill or a path is very important, right? I don't like walking uphill. The slope is very much a concern when I'm walking up a hill or running up a hill, right? The pitch of a roof, how steep a roof is. If you're talking about science and business applications, you talk about in chemistry, how rapidly something dissolves. That's a slope, right? That's a rate of change. Your sales over time, you can talk about a slope there, okay? You can talk about variable portions of costs in accounting, okay? So for it may cost you $1,000 a month for rent, but then for every item that you produce, you're also spending, X dollars. That is an application of slope. Okay. You're going to want to be careful when you're talking about real world applications. Be very careful with your units. Okay. Be very careful with your units. Let's talk about the example for the grade of a road. If you're traveling on a road with a 5% grade and you're going uphill, how many feet do you move vertically if you go forward 3,000 feet? Okay. A 5% grade is the same thing as telling us that we have a 5% slope. Okay. So 5% grade is a 5% slope. Now 5% again isn't very helpful. So our slope in decimal form is 0.05. Okay. So that means that how far we go vertically over how far horizontally has to be about 0.05. Okay. So we don't know how far vertically. Okay, that's what we're finding. But we do know that we went 3,000 feet to the side. So 0.05 has to equal h that we're looking for divided by 3,000. Now solve for h. Multiply both sides by 3,000. So 0.05 times 3,000 is going to give us h. And if we plug that into our calculator, we're going to know that h is going to be 150. And you can check that. Check in your calculator. Is 150 divided by 3,000? So if I go up 150 and over 3,000, is that going to give me 5%? And it is. Our units here are feet. You can keep the units throughout the whole way. That's good scientific practice. Typically, bad scientist, I typically note what my units are going to be in my final answer, and then I go from there. Okay, let's look at another one. Great place to pause and make sure you can repeat this. If you're traveling on a road with a 4% grade and you're going uphill, how many feet do you have to move vertically if you go forward 1,500 feet? So we know we're going horizontally 1,500, and we need to know how far we're going high. Okay, so how up are we going? And we know that our slope is that 4% grade. So we know that 0.04 is how far we go vertically, which is what we're looking for, divided by how far we went horizontally, which is 1,500. So 0.04 times 1,500 is going to give us our h, which if we do that in our calculator, it's going to give us 60. So we know that we're dealing in feet, so we know that our answer is 60 feet. And again, we could check that. 60 over 1,500 is going to give us 0.04, which we know is 4%, so yay. Okay. Now the pitch of a roof is its slope. And there's a lot of lingo that goes into pitches of roofs, and I'm not going to get into that, okay? Just know that the pitch, like a lot of times they're in 12th, okay? The textbook gets into a little more detail about that. If construction's your thing, definitely take a look at that. But, most of us probably won't need that. Culinary, you're probably not going to ever need to know that it usually comes in 12ths, okay? And if you do at any point, remember, it's just a fraction. Type it into your calculator and you can know what the decimal form is if you're more comfortable speaking about that. So if we're talking about the slope of a roof, we're talking about this line right here, right? This is our roof. Here, this is a 5/12 roof, okay? Because we go up 5 feet for every time we go 12 feet across. So our slope is 5/12. Here, our slope is 10/24, which if we're wanting to put it in 12ths, we can simplify this to 5/12. These roofs are not the same size, right? But they are the same slope. And we'll get into that with similar triangles in Unit 4. But just know that slope does not determine size necessarily. It's just talking about that angle. So let's take what we just learned about the pitch of a roof and let's apply it, okay? If we know that a roof has a pitch of 4/15, we want to find its height, okay? We know that horizontally it's 20 feet across, but we do not know that height, okay? But we know that this slope, which is another word for the pitch, is 4/15. So we know that 4/15 is the same as 8/20. Now we can multiply by 20 on both sides. So 20 times 4/15. I would certainly do that in your calculator. That's going to give you H. And so if we are careful here, we will plug that into our calculator. I'm going to get 80 out of 15, which is going to give us, if we want it in decimals, 5.33 roughly feet. Okay. So remember that slope is the same thing as grade is the same thing as pitch. These are just fancy words depending on the area of study. Yet another word for slope is the rate of change. I guess that's more than one word, so it's a term. Okay, and this is sometimes it's in a lot of different areas. We see it in math too. Okay, rate of change interchangeably with slope. So the rate of change of a person's weight compared to the height, if their weight is 120 pounds when their height is 62 inches, and their weight is 150 pounds when their height is 68 inches. Okay, don't get bogged down here. Okay, weight compared to their height. So if we're talking about weight compared to height here, we want to compare pounds to inches, okay? Weight compared to height. So we're going to talk about the change in weight over the change in height, okay? The change in the weight is this 150 to 120, okay? So you can write these as points too, right? When they were 62 inches, they were 120 pounds. And when they're 68 inches, they're 150 pounds. So our change in weight is that 150 minus that 120 pounds over that 68 minus 62 inches. This is 30/6 pounds per inch, which is going to give us 5 pounds per inch. That is our rate of change. So for every inch that they gain, we expect them to gain 5 pounds. So weight compared to height tells us which way to go. Weight comparing to height. Great place to pause and make sure that you're understanding things. But Susan's salary was $45,000 in 2015 and it was $54,000 in 2020. What is the rate of change in salary with respect to the number of years? So change in salary, I'm going to use the delta here. If you guys have taken science, you'll see that that just means change in salary over the change in year. So how many dollars per year is she changing? That's what we're looking for here. So we know that she has 54,000 from 45,000. 2020 compared to 2015. So this is going to be $9,000 for 5 years. So if we do 9,000 divided by 5, that is going to give us in our calculator $1,800 per year. You could also write this as 1,800 per year. Okay. Now notice I always do the later compared to the first, but if you had done it the other way, that's totally fine. You'd say, okay, well, 45,000 minus 54,000 over 2015 minus 2020. As long as you're in the same order, remember, it doesn't matter. Because here you're going to get negative 9,000 over negative 5, and those negatives are going to cancel to be positive, so it's going to be the exact same answer. So it doesn't matter which one you use first, as long as you're in the same order. Okay, what about this one? The number of gallons in the gas tank of a car changes from 15 gallons to 10 gallons during the same time. The mileage changes from 15,000 to 15,225. What is the rate of change in miles traveled with respect to the gasoline in the tank? So with respect to, so we're talking about miles with respect to gallon. So miles per gallon here, okay? So we're talking about the change in miles. So change in miles is here, okay? So 15,225 minus 15,000. And the number of gallons was 15 to 10. Now be careful here, okay? Because the second time it was 10 and it started as 15, okay? Sometimes, again, it's good to write the point. So you had 15 gallons at 15,000, and you only had 10 gallons at 15,225. So this is going to be 225 miles per 5 gallons. And if we do that math here, it's going to give us negative 45 miles per gallon. Okay. The rate of change with gasoline. Okay. The gas is, this negative just tells us that, hey, as your miles go up, your gas is going down. And that makes sense, right? We don't get more gas in our tank as we drive. That would maybe be nice, I guess, to a certain point. So the negative makes sense here. Now, obviously, we don't think about that, you know, in a car commercial or whatever. We don't say, oh, negative 45 miles per gallon. That's because it's understood that, hey, it's going down, right? You're going to get 45 miles per gallon. But we're not talking about the actual rate of change of the gasoline, because the gasoline is decreasing as you drive. So just be careful here. Now, this, I will admit, is not my favorite example, but it's good to think about, okay? Variable costs in a business. So if you're taking any business classes, you've probably heard about fixed costs and variable costs. And fixed costs are things like rent, things you're going to have to pay no matter what, no matter how many you make or how many you sell. So usually rent is your big one. I just like to use that as my main example. No matter what, even if I go on vacation for a month, I still have to pay rent. Variable costs depend on how many you make or how many you sell. Okay. So things like, you know, material costs. If you make 100 of something, that's going to cost you more than if you make 5 of something of the same item. We can estimate our variable costs by comparing 2 points. Okay. Now, notice here that this is an estimate, because it's not, the real world's messy, right? It's not going to always be the same. What you want to do if you see one of these on a test is pick 2 points. Okay. I don't care what to unless I tell you what to. And then we're going to talk about the variable portion of the shipping expenses based on how many units are sold. So our expense is Y and units sold is X. So using these 2 points, we'd have 145,000 minus 170,000 divided by, doing it in the same order, 18,000 minus 17,000. That would give me negative $25,000 over 1,000 units, which is going to give me let's see, this is going to give me negative $25 per unit. And see, to me, that one doesn't make sense, right? Because I'm paying more here when I made less. We must have gotten a deal on shipping. But if I picked two different points, let's say, if I had picked this one and my original one, okay, then I'd say, well, now I have 292,000 minus 145,000 over 22,000 units minus 18,000 units. Now this is going to give me $147,000 over 4,000 units. So this is going to tell me something much more realistic. If I plug this into my calculator, it'll tell me somewhere around $36.75 per unit. Okay. So again, this one would vary greatly depending on what you chose. That's fine. Ugly real world. Again, we must have had a coupon this year. Okay. Or maybe we had to pay major setup for something here. I don't know. But if you were to find something like this, make sure that you know what the reference points are if they're told, or make sure that you show, okay, I used this point and I used this point. Let's do one final example with the pitch of a roof, okay? So what would be the pitch of a roof if the house here, shown here, is 28 feet wide and the rise in the roof is 7 feet, okay? So this right here is 7 feet and this whole thing is 28. So we want to talk about how far we go vertically over how far horizontally, right? We know that vertically we're going up 7 feet, right? But think about horizontally. Are we going 28 feet across? We're not, because all we care about is one of these, okay? They're identical, so it doesn't really matter which one we want. But either way, we know this is 7. This is the slope we're looking for over here. What is our horizontal here? Well, it's split in half. So it's going to be 14. It's going to be 28 divided by 2. Either way we do, we know we're going up 7. And we know that we're going across 14. Okay. So the pitch is 7 over 14. Or if you want to write it in common form with the 12s, that would be the same as 6/12 because it's 1/2. You could also say it's 1/2 or 0.5. Okay. Be careful and pay attention, especially if you're someone that will use this in your job. You don't care about how far across the whole thing is. You only care about the one line that you're looking at. Okay. So here we have to split it in half. That was a lot, wasn't it? So the key here is to remember that a positive slope or positive rate of change means that y is getting larger when x is getting larger. Okay, they're going in the same direction. A negative slope or negative rate of change means they're going the opposite direction. Okay, so y gets smaller as x gets larger. As one grows, the other drops. Sometimes we see a 0 slope, and that just means it's not going up or down. It doesn't matter what we change about that horizontal. We are not going up, we are not going down. Remember, if you have questions, you can go to the Math Center. They have virtual tutoring also. Check out their website. You can certainly check your text for practice. I hope you guys are all reading your textbooks. You can use the references in Blackboard. There are other lectures, other videos, other lecture notes that you might find helpful. And remember, last but certainly not least, you can ask me. You can send me an email, you can join office hours, however you need. I encourage you with these, especially as we get into more material through this course. If you get frustrated, take a break, okay? Take a break. Don't necessarily ask for help immediately. Don't discount yourself immediately. Take a break, come back to it. If you're still frustrated, look for help, okay? Remember, you have assignment 3 coming up due soon. Please check your course schedule. And otherwise, thanks for listening, and I will see you guys next time.